Hello everyone, in this video we're going to talk about domain and range for rational functions. Let's talk about this. Alright, so there's two different notations we're going to be focusing on. Set builder notation and interval notation. We've been seeing these two notations all year, but it's good to recap the difference between both of these and what they're going to look like. Okay, some symbols we're going to be looking at is, depending on whether we're dealing with x or y, we're going to have this notation right here. This means the set x is the set of all real numbers. And we'll say x or y because that'll change for domain and range, is the set of all real numbers. And all this means is that we're going to go from negative infinity to positive infinity. Everything exists from negative infinity to positive infinity. This is what that means, right? This is the notation we're going to be focusing on for set builder. Now for interval notation, this is where we use the letter U for union, and we're combining things, right? So as a quick recap, we're going to have, to say it's the set of all real numbers, we usually just say negative infinity, comma, positive infinity. This is the starting point, and then the ending. And then the parentheses means that it's not included. And the brackets means that it is included. And what I mean is that the endpoints, whether we have a bracket or parentheses, it means that that point will be included or that point is not included in part of the process. And you could even have one where it doesn't include it and includes it, a little bit of one of each, depending on the endpoints and what those locations are, including the point or not including the point. So let's get to it. Let's start with domain. The important thing to focus here when we're dealing with domain is focusing on the vertical asymptotes. So I always want to identify my vertical asymptotes for domain. Okay, so the vertical asymptote here we have at x equals 1. The reason why I want to focus on vertical asymptotes is because this is the value, if we remember from vertical asymptotes, that the function is not going to exist at, right? We have this asymptote, this imaginary line that the graph is never going to touch or reach. So the function exists everywhere, and it's going to try to get to 1, but it'll never actually reach 1. Even on the other side, it'll go above 1, like 1.1, but anything close to 1 will not exist. So there's going to be a gap here at x equals 1. So what we can say is we can say x is the set of all real numbers, meaning x is going to go from negative infinity to positive infinity except 1. This is set builder notation, where we're saying everything from negative infinity to positive infinity will exist except for 1. For interval notation, I like to think of this as how many intervals are we going to have, how many really kind of graphs are we going to have in this picture. And there's two intervals. There's the interval that's here on the left, on the negative side, and then there's another interval that's happening here on the right. So this graph is sort of split up into two parts, two intervals. And the way to say it is like this. We said that the function goes from negative infinity to the first asymptote. And because it'll never reach 1, it cannot include it, so we put a parentheses. We put the letter U for union, and then we say that it goes from 1 to positive infinity. And what this says is that the function will exist from negative infinity to infinity with a gap at 1. We put the letter U for union, saying that there's a disconnect between the left side of the graph and the right side of the graph. So this really tells me that there's two intervals, the interval on the left and the interval on the right. Both of them saying that there's a gap at 1. So this is really it. We're looking at the vertical asymptote to tell us everything's going to exist except for what? Let's try a few more. Notice how here we have two vertical asymptotes. 1 at negative 2, and 1 at positive 1. So what does this say? It means that everything on the graph is going to exist except for these two x values. These are the two x values that I'm interested in not existing in the graph. So how do we say that? Well, we can say x is a set of all real numbers. Let me make more space. X is a set of all real numbers except negative 2 and 1. It's all the x values except for these two. Now we're thinking about interval notation. Now how many intervals do we have? How many parts to the graph do we have? There are 3. There's on the numbers on the left, in the middle, and on the right. So there's 3 intervals for this, which means when we're looking for the union or the disconnects, we're looking for 2 disconnects. One happening at negative 2 and one happening at 1. And this is how we would express it. We would say the graph goes from negative infinity to the first asymptote. There's a gap here at negative 2. It picks up at negative 2 again, and it goes all the way to 1, the next asymptote. And then it goes from 1 to infinity. Notice how we have 3 intervals here. We have the first interval, the middle interval, and the right interval, with there being a disconnect at negative 2 and a disconnect at 1. So the vertical asymptotes really determine what the graph looks like. Let's try this last one. Why don't you give this one a try? Press pause real quick, solve the problem yourself, and see if we get the same solution. So, regardless of whatever the graph looks like, it might be crazy, it might look weird, it might look like whatever it is. Remember, domain is about vertical asymptotes. So here we have a vertical asymptote at negative 3, and here we have a vertical asymptote at 1, which means the graph will exist everywhere except for these 2 locations. So x is a set of all real numbers except negative 3 and 1. Similarly, because we have 2 vertical asymptotes, we're going to have 3 parts to this graph, 3 intervals. We're going to start at negative infinity, and it goes to the first asymptote. There's a gap here. We put the letter u to disconnect it. We pick it up again at negative 3 to 1, and then at 1 there's another disconnect all the way to infinity. I like to think of interval notation as how many intervals are there on the graph, how many parts of the graph exist. And there's 3 parts, so I have to put 3 separate sections connected with a u between those sections. Now let's talk about range. So I'm going to do the exact same 3 examples we did earlier, but instead of focusing on domain, we're going to focus on the range. Now range is the set of y values. So now we're looking at the y-axis, not the x-axis. So the asymptote that affects the y-axis is the horizontal asymptote. And here we have y equals 1. We have an asymptote at y equals 1. Very similarly, we're going to now look at the graph vertically. So we're going to say that y is a set of all real numbers except the horizontal asymptote. Very important that we focus on that here. So now we can change the symbol to y is the set of all real numbers except 1. Because notice how there's a gap at 1. The graph will go up and up all the way to 1. There's a gap here. It'll pick up again and go all the way to the top. So now that we're focusing on the range, we're looking at the horizontal asymptotes instead of the vertical. But it's going to be very similar notation. If I'm looking at the graph vertically, there's 2 parts to the graph. There's the bottom interval of the graph and the top interval of the graph. There's 2 intervals, right? So there's going to be a letter u between these 2 sections. Now, when we're dealing with horizontal asymptotes, we could have 1, 2, 3, when we're dealing with vertical asymptotes earlier for domain, there could be as many vertical asymptotes as we wanted. For range, we're only going to have 1 horizontal asymptote. Only 1 can exist. So there will always be only 2 intervals. The bottom part of the graph and the top part of the graph. Always. So this is how you would write it. We would say the graph exists from negative infinity to 1. There's a disconnect at 1, the y value. and then from 1 to infinity. So always focus on the vertical asymptote to write your range. In this example, notice how we have two vertical asymptotes. It doesn't matter. We're focused on the horizontal being at 0. That's what we're focusing on. There's only two intervals here. The top part of the graph and the bottom part of the graph. Okay? So everything's going to exist except for the horizontal asymptote. So we say y is the set of all real numbers except the horizontal asymptote. Because if you notice the horizontal asymptote, it does not cross. It does not cross the horizontal asymptote. Nothing touches this line right here. And that's not always the case. But in this scenario, it doesn't. So we can say it goes from negative infinity to the horizontal asymptote, which is 0, and then from 0 to positive infinity. The bottom side of the graph and the top part of the graph. In this last example, notice how the horizontal asymptote is at -1. So normally we would say everything except for -1. But notice how here it does actually cross the horizontal asymptote in the middle. So sometimes when you have multiple vertical asymptotes, the graph can cross the horizontal asymptote around the origin. Horizontal asymptotes tell us more about what happens in infinity and negative infinity, and it's approaching -1 and approaching -1 on this side. But when we look at the graph, we have to pay attention, does it cross the horizontal asymptote? If it does, then there's no except. We just say y is a set of all real numbers. We don't say except for -1, because this time it does touch -1. So the horizontal asymptote makes no difference here. We just say it's a set of all real numbers, or from negative infinity to positive infinity. There's no interval here because everything exists from the bottom to the top. Everything exists. There's no gaps. So let's review. When you're dealing with domain, we're looking at vertical asymptotes. So we want to say everything except vertical asymptotes. And we have different ways of saying that, right? We can say it goes from negative infinity to positive infinity except these vertical asymptotes in interval notation or set domain notation, set builder notation. For the range, we're looking for everything except the horizontal asymptotes. Now here you have to pay attention to the origin. If we have multiple asymptotes, make sure you check the graph to see if it crosses the asymptotes. So sometimes, if it crosses the horizontal asymptote, it goes from negative infinity to positive infinity. There's no except. So this one's very important to check, okay, for the range. We're going to mainly be focusing on the domain for this unit, right? Focusing on the x values, the vertical asymptotes, and what exists and everything that doesn't, right? But this domain and range definitely ties into vertical and horizontal asymptotes. So if you're struggling with understanding what a vertical asymptote is and how it functions, check out the other videos that talk about that. All right, I hope this has helped. You guys have a great day, and as always, we'll calculate later.